reacting responsibly. It's actually the presentation, you know, it evolved ever since I coined this actually pretty bad title. So it's not really going to be reacting responsibly, let's build a state management solution that doesn't overreact, but it's sort of going to be like that. We're still going to build a state solution that doesn't react. It's just going to be more interesting, I hope. So before we begin, I'm Eugene, or Yevgeny, or Zhenya. It's mandatory for me to tell you that I love cats. It's also important for me to tell you that I tinker with electronics, although I usually look like this guy right here when doing that. I'm also fond of romantic roams through Wikipedia, and I love all the books. Oh, and I'm also a developer in Remitly, an infrastructure developer. So that's about me. Are you ready to talk about state? Yeah. Great. I know, it's exciting. But let's start with the basics. What is state? Can someone tell me? But not really what is state. What is state for a front-end developer? Because I don't want to go too philosophical in here. So if no one has like a concrete answer or, you know, a pickup line, I'm going to give you my own definition, which is state is the what that determines how your UI looks and behaves at any given moment. Does that make sense? Sort of does, right? Well, we'll get to it. But remember the what. The what is important. OK, so we know what state is. How about state management? What is state management? Well, I've got an answer for you for that, too. I actually got 4 answers, or an answer made out of 4 WH questions. So I call it the essence of state management. And I think I should have called my slide that. The first one we've already seen. It's the what. The what is basically what we're managing, the state, what we want to, basically what decides what our, it's basically what makes our application interactive. Now, in order for the application to be interactive, we also need a how. Like, how do we interact with a state? Do we simply change it using getters and setters? Do we use direct mutation? Do we maybe use proxies? Has anyone ever used MobX? I'll get to that later, too. OK, the third WH question we need is a who. A who is basically, well, who's showing the state? Who is responsible for showing the user what has changed? And who is responsible for showing the user the state when it changed? Which is the next and final WH question, the when. So the internet connection is unstable is not part of the slides. The when is basically like the efficiency of state management. Do we react all the time? Do we react granularly? And what does it even mean to react? OK, so armed with all of these WH questions, let's actually talk about what we can do with that. So imagine that we distill this into the simplest form we can. So those 4 WH questions, how small can we get a state library to be, to actually be functional and work as we expect as front-end developers? Now, one thing that I do want to mention is that I'm assuming that people, like I'm thinking in React here, but the state management library that we're going to talk about, like all the state management libraries aren't React native. Like some of them are, like Joai, but a lot of them are basically agnostic. You can use them across different frameworks or stacks. OK, now having said that little caveat, here's what I built. This is tiny state. It's less than 30 lines of a state manager with React bindings. And it's production ready. I mean, I think so. By the way, when I say production ready, I mean that you can grok what you're looking at fairly simply. Like if there are any bugs hiding here, you only have to scan through 30 lines. OK, so let's talk about this. Let's go through this and actually see what it does. So the first thing that we need is, sorry, I forgot I put this slide here. What does each piece do? Like what does each function in that create store function do? Also, what we'll be talking about is why did we make these specific design choices? Like, I'll ask you a couple of questions later about the specific design choices that I'm talking about, but for now, just let's keep that in the back of our minds. And finally, I mean, it doesn't make sense unless it all works together, right? So we'll get a demo to show you that it does. All right. Finally, we can talk about the code. If the slide will work. If the slide will work. Oh, that's great. Thank you. OK, so at first we have state. Let me just show this a little bit bigger here. The state is the what, as we've said. It's basically what we're showing. The listeners is a set, which is basically like a fancy array without duplications. And that will hold all of our consumers or components, or basically the Who, which is a great band, by the way. Next, I mean, I guess this is pretty simple and self-explanatory. Next, we have this thing. It's basically a function that returns the state. It exposes the what, as in a comfortable, like in an interface that is based on a function call. Now, why? Like, why do we use a function? Why don't we just return the state? Does anyone care to venture a guess? It's fine. Yeah, go ahead.
Maybe some middleware function where you want to modify the original state or.
Okay, so what's your name? Golan. So Golan says maybe we want to modify the state in between, before we consume it, right? That's a good point. Anyone else? Yeah.
You don't mutate the state. You replace the value to a new object. If you will return the state, once you call set state, the captured variable that you return in the object won't change. The captured variable that you return in the object won't change, but the local variable will.
Did you see my next slide? Because it's basically what you're saying. So excellent. Both of these are true, by the way, but in my specific implementation, let's consider the following example. So we create a store, we put count 0, and then we reference it. And then we change the count using setState. Now, what would be inside of the reference? Like if we call reference.count. Also, imagine all of this is inside of a React component. I'm sorry, I didn't do that. But if anyone cares to venture a guess, the number will be, yeah. Who said that?
I said that. It will be 0 because it will be re-rendered only, it will be changed only the next render.
Exactly. Thank you. What's your name?
Ole.
It will be 0 because it will only change in the next render. So again, I'm sorry, but imagine all of this is like inside of a function. So if we actually use a function to return the state, we always get the freshest state possible. So count here is 0, then we update it, and if we still access it through the get state, we get count 5. Okay, let's keep going. The subscribe function. Okay, now things are getting a little bit interesting. So it is my contention that every state management solution needs to have some sort of pub-sub mechanism, like publish, subscribe. And in this case, it's really simple. It's just we're passing the subscribe function the who. It's the listener. It's actually not us that are doing that in the context of React, but I will show you that later. Then we add the listener to our listeners, and we return a cleanup function, which again is it's good practice, but it also works well with how React manages lifecycle events. So React will use this cleanup function later, so that our memory won't be full of useless event listeners. All right. Now, this is the bulk of the state management function, I would say. This is the how. So what does the how do? Well, the how is calling getState, and we're modifying the what, which is the state. And notice that we're checking if the state is a function. If it is, if state or fn is a function. If it is, we're just applying it to the state and returning the value. Otherwise, we're just, spreading the love. Now, the important thing is to tell everyone that we did that. So here, we're calling for each, so that React and basically our who's will know that they need to re-render. Okay. Another question. Why state or function? Why not just state? Anyone? Don't be shy. It's okay. Consider the following example. So we have a counter component, and let's imagine that we're an angry customer and we click on this button a lot. Now, I want to say that it's either this or that, right? It's not both of them, but I'm just trying to give that an example, and we're returning some stuff. It doesn't really matter what we're returning. Let's focus on the count and let's focus on the click. Now, what would happen if I click really fast, like 5 times, and I'm super fast? What can possibly happen? Not surely, but what can possibly happen? We can have race conditions. Thank you for looking like you were about to say that. The race condition might occur if we're doing this thing, right? Imagine that this counter wasn't re-rendered yet. Okay, so React it batched the result. It didn't call this function again. But on click, it's it's a side effect. It lives outside of the scope of the component. So if you click on it a bunch of times, as long as the counter doesn't re-render, you're just setting the same state over and over and over. Does that make sense? Thank you. All right, let's keep going. This is the React bindings, and it's very simple. Has anyone here ever used useSync external store, or ever heard of anyone else using it? It's a hook. It's being exposed by React, and it's basically what it says on the lid. It's syncing your external store with React. Okay, well, how does that work? Well, first, before, what is this selector here, right? Why do we need this? Well, the selector is basically what allows us the granularity that we're looking for. We don't really want to update a state. We don't really want to re-render all of the components that are dependent on this big glob of state. Perhaps we only care about the counter. Perhaps we only care about the username. I'll show you that in a bit. But what's important to see here is that this selector, which by default returns the entire state, is also what we're passing here. So the first line, store subscribe, this is basically what React uses internally to pass in that listener. It passes in a reference to itself, or not itself, but something in itself, and that allows it to know which components need to be re-rendered. The next line is basically the get snapshot. The get snapshot is, okay, what's my state? What's my current state? And it can't be stale. So this is why it's a function. And if you see, we're wrapping the function with the selector, which will actually give us that granularity. Okay. What do I have here? So here I'm trying to explain why selectors are awesome, which is what I did right now. Let's look at this example. User profile, it basically uses the store, and the store in this case is just username and count. So we're using the state, and we're only rendering the state username. But if, let's say, I change the count, this will re-render again. And that sucks. I mean, it doesn't suck in this particular case because our computers are all powerful, but imagine you have a list with like a gazillion entries. With selector, we're basically just getting a stable reference. We're telling the useStore method exactly what we care about. And if you ever use Redux, it's basically the same thing. In this case, the username, the better user profile will only re-render if the username changed. So if we change the, let's say, count, it won't affect this one. And if we change the username, it won't affect the imaginary component that holds the count. And I didn't have space in the slide. Okay, let's show you that it actually works. Awesome. So I made a little demo. I hope you can see it well. Just so we're all on the same page. This is the implementation itself, except for the import. It's all there. Sorry. What I was saying is that this is the implementation that we have in the slide. I promise, pinky swear. Okay, now let's actually close this, and let's minimize this, and let's make this a little bit wider. Okay, so we have two examples. The first example is useState and useContext, the naive approach to state management. And I want to see what happens when we click on these buttons. Okay, so it works. React works. Excellent. But do you see those little flashing lights? I don't know if you can see them on the slide. Yeah. This is basically a tiny component that I attached or basically wrapped everything with, and it flashes when the component is being re-rendered. So as you can see, with the naive approach, because we're using useState and useContext, and we're wrapping the entire component with the context, it will re-render everything inside of it, even if that data doesn't change. Now, because of those little selectors that we added to the tiny state counter, my solution is just so much better. Look, beautiful. Okay, enough demoing. Let's talk about some other stuff. So this slide is important. We just created a state management solution with 30 lines of code. Why do we need anything else? Well, because I say, Jesus Christ. Because of patterns and ergonomics. Now, what does that mean? Well, let's talk about it. Let's look at some concrete examples. Oh, yeah, thank you. Do you know who this is? This is Joai. Has anyone ever used Joai? Well, OK. Joai is basically like taking your state store and decomposing it into its components. So instead of, how did that pitch get there? Go away. It's basically breaking apart the monolithic state or the singleton that we're using in stuff like Redux or, I don't know, other state solution management stuff. And we're decomposing it into little units called atoms, which allows us to have precise state updates. So like we did that whole thing with the selector. Because it basically flips it on its head, you don't need selectors. You have the opposite problem, if you will, if you want to compose all of your state together. So the pitch for who wants to use this cute ghost is that it's perfect for dashboards, perfect for all sorts of applications, web applications where you have widgets that are components and they're not necessarily part of the same state tree. Maybe, sorry, not state tree, part of the same React tree, right? So you can't just wrap them with a provider, or if you can, you'll be wrapping too much. And that's why this is pretty good for that thing. It also has a pretty simple API. I will show you what I mean in a second. And it doesn't have a lot of boilerplate. Redux. The anti-pitch is, of course, that if you decompose your state enough, and then you have a complex enough state, you sort of kind of want to compose it again together. Like you want to have everything in the same place. And if it doesn't work, it becomes unwieldy. Also, a simple API does not mean that it's a robust one. It's not even about robustness. It's just that simple things are simple, but you don't necessarily know the correct patterns or how to use them. So basically what I'm trying to say is that if you use Joai to manage your state, all of your state, well, good luck. The other thing that we know and love is Redux. So I guess everyone here, or at least part of you, have used Redux. What's the pattern? Well, it's basically Flux. If anyone has ever heard of Flux, it's a unidirectional data flow sort of thing that is really easy to think about. You're basically dispatching an action. An action is just an object. Then that action is being fed to a bunch of reducers. And then those reducers, you combine the result of these reducers and you get your new state. Ta-da! It's really easy to think about. But, oh, and it's also customizable, like you have middleware. And another thing, you have a really, really great community. Now, when I say great, I mean opinionated. And I think that's good because it allows you to turn off your brain and just, think about the correct use cases. But also, you don't really understand why. The good thing is that if you've ever wanted to know how do you do X with Redux, there's probably a Reddit post about it. Okay, so that's the pitch. Also, because it gives you so much structure, like so much structure in terms of boilerplate, it's pretty good for distributed teams. Like if you are working with people from United States, like I do, or with Ukraine, like I do, then, well, everyone knows Redux. It's like a lingua franca of state management. And because it's so well established, it's easy to work with, until it isn't. Until you've got, slices galore, until your state contains like gazillions of selectors and sub-selectors that use other selectors. So if you're allergic to boilerplate, or if you don't like strong opinions, or if your project is small and you don't work across large teams, you might not need it. All right, what else do we have? MobX. Who has ever used MobX? Excellent. What does MobX do? Well, Well, that's actually a good thing. Well, concretely, its pattern is reactive programming using observables. Now, I'm not going to talk about observables, but as the name suggests, you can observe them. It's also very object-oriented. So if you love object-oriented stuff, not dissing anything, the main abstraction pattern of MobX is classes. Okay? So what do you use it for? Well, it's really great for apps with like complex state management. Or not even complex state management, think about complex data models. Think about a user that has like a ton of fields and a bunch of actions that are attached to it. And maybe then you have like a list of users or a library of users. So when you have these relationships between robust data models, you sort of want to, I mean, it's not that you sort of want to, it's that it's really easy to start with MobX and just put a store inside another store. The problem is it gets really messy really fast. Quick example, in Wix, we've built Wix automations, which is like if this then that, but for Wix stuff. And we used MobX state tree. We used MobX first, and then we used MobX state tree, which is like an opinionated MobX. And at first it worked really well, and then nobody could understand the code, and then we rebuilt it with something else. So it's great to start with complex stuff. I'm not sure it's a great finisher. All right, now, last but certainly not least, XState. I'll run through this because I want to show you a demo, and the nice lady there says that I don't have enough time. Declarative finite state machines. Basically, if you studied computer science, it's one of the first courses. If you've ever heard of a Turing machine, well, it's not, it is. It's like a generalization of that. It's really good for multi-step workflows, and I will show you exactly what I mean. And it's really bad if you don't know what a finite state machine is, or if you don't care to learn. And it's pretty much an overkill for anything that is like a simple CRUD-based app. All right, so we're done. Let's look at some demos. Okay. I'm not going to show you the code here because, well, I don't want to, because I like you and I don't have enough time. But it's all available. It's free, open source, whatever you want to do with it. I'll just show you the little comparison that I built here. So let's start with Joai. So as I said, it's really good for dashboards. What do I mean by that? Well, look at the code that is actually responsible for setting up this state management. It's really small. Like, you've got atoms, and they consume other atoms, and you get out of the box all of these awesome interactions where you can just components can react to one another. You get a bunch of things that are changing. You got these recommendations showing. Not a lot of async stuff, not a lot of requests or any complex logic. But if you have interdependent components that share a simple state, it's really awesome. MobX. The example here is of a real-time trading dashboard. I don't know how they look like, but I asked ChatGPT, and that's what he gave me. I don't know how to design, but the logic is mine, I swear. So here we have computed values. They're shining in a different, a little purple, and the actual, not computed values, the actual values themselves that the computed values are derived from are in blue. And as you can see, we're just basically doing a price update every 2 seconds, and that's why it's flashing. But what I wanted to show you here is that, well, actually, I don't have enough time, but in the code, believe me, that you just wrap a component with an observer, and then you just use the prop. So like in this case, the prop would be portfolio value. It will automatically or automagically update your component when that value changes. Redux, not much to say about it. Like everyone knows how to use it, but since it's really easy to create a future state and undo and redo functionality because, well, it's immutable and blah, 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 blah. So there you go, undo and redo functionality, perfect. The last thing that I wanted to show, and actually the most interesting one, is the XState solution. So obviously that's not the entire state machine, but I hope it's representative enough. Let's see what happens if so basically the use case here is that you have a flow, and that flow is complex enough that you need to change, like that. Let's look at sorry, I'm showing you on the screen and not on the, let's go. If I select the country Nigeria, it will allow me to do a bank transfer. So if I go next, I get this form for a bank transfer. But if I select United States, this form is different. And if I don't pass validation, nothing happens. Now, believe me when I say that I didn't wire this button to do nothing. This button is actually sending a state update. It's just that because XState is a finite deterministic state machine, there are no undefined states. There are no incoherent states. So if it can't transfer you to a different state, it will just stay in the same one. It's just for brevity's sake. No, sorry, just for completeness sake. Let's finish this. Let's do next. Account number. That's mine. Review order. Confirm order. Beautiful. That is basically it. So before I leave you with the awesome speakers that we have after me, I would like to, what is it? What is this? Never mind. These are my nice and accurate conclusions. Patterns solve problems. Libraries implement patterns. So different apps need different patterns, as I've mentioned before. If you're using just a simple to-do app, use a simple useState. If you're building multi-step flows for a financial system, use XState or MobX. And start simple. Evolve as the complexity evolves. If the complexity does not scale with your solution, don't jump on the hype train. Basically, that's it. You can use these links. I will share them later. The demos are fully interactive. You can edit them, do whatever. And of course, the slides will also be available. Questions, feedback? No, thank you. No, I'm kidding. Questions, feedback? Thank you. Oh, awesome. All right, that means that I actually need to.
Yeah. What about the Zustand and the basic context?
That's an excellent question. The question is, what about useState, which is another state management solution? And what about simple useState? useState and useContext, right? Well, useContext in itself doesn't store state. It just stores something. And it doesn't react to changes in that something unless that something lives inside of a state. And once we start doing that, useState plus useContext, we get into a place where we need to think about optimizing stuff, using useMemo, useCallback. So I didn't want to show that because it's what we all do. And Zustand, well, I didn't show Zustand because Zustand is actually tiny state. Tiny state is basically Zustand shrunk down to even more Zustandy. So yeah, does that answer the question?
Thank you.
Yes?
Where do you pick up React query for state management?
Excellent question. So what's your name?
Joseph.
Joseph. So Joseph is asking, what about React Query for state management? My opinion is, and that's actually also the opinion of Tanner, who's the creator of React Query. React Query is for server cache. Now, we have this understanding that, well, if it's on the client and if it changes, then it's state. Well, like in my head, there's client state and then there's server cache. If the source of truth is the client, like a toggle, then it's client state. If the source of truth is a user object, that its balance changes, but its balance doesn't change on the client, it changes on the back end, that is server cache. So I use React Query to handle all of my server cache needs, which, to be honest, is most of what you need. Like a lot of the state that lives inside applications, our applications, I would argue, is actually server cache. So that is an excellent question, and I just do that separation. Like, for example, in our Circle application, the state is so minimal. Yes, we use Redux, but it's so tiny that it's actually not that painful. Most of the things that we do, or most of the things that we interact with, are server cache, and instead of React Query, we're using Apollo because, I don't know, we made a bad mistake along the way. Any other questions? Yes?
So why shouldn't I use Redux?
So the question is, why shouldn't you use Redux? Well, if you're building a to-do app, or if you're just playing around with like a framework or something, or if you're building a personal project that is not complex, I wouldn't start with Redux because like, it's easier to understand the fundamentals if you're using something simple. So whether it's my ugly tiny state or Zustand, which I, again, urge you to look at the code. It's really simple. It's just a page of like 130 lines, 70 of them is types. So when should I use Redux, or when should you use Redux? Well, don't listen to me because, you know, it's just one person. But if you do listen to me, I say start with the simple stuff. Start with useState, use context, throw a little memoization there. You won't even need to because React 19 is just arrived, and the React compiler basically deals with all of that stuff for you. So if you're working with more than one person, or if, like, let's say if you're working with more than 4 people, and maybe one of those people doesn't come to the office that often, that's a good place to start using Redux. Excellent question. Thank you.